Good morning, dear students. Today we are taking the second chapter, the measurement of the length. In the second chapter, units and measurement, we are taking the subtopic measurement of the length. Now see, measurement of the quantity. We are taking the length, mass and the time, basic quantity, in which first measurement of the length. So to measure the length of the object, we are using the three types of the method, in which one is the direct method, second is the indirect method, and third one is the monomolecular layer method. So in the first method, that is the direct method. What is the direct method? The distance or the length which we can measure directly with use of finite device like scale, measure tapes is known as the direct method. Suppose we are taking the meter scale, then meter scale range we are taking as a 15 centimeter to 100 meter. Second, vernier calipers. Through vernier calipers we can measure up to 10 raised to minus 4 meter, 0.01 centimeter. If we are taking the micrometer screw, its least count is 0.001 centimeter or 10 raised to minus 5 meter. So with the use of micrometer screw, we can measure the diameter of the small sphere as well as the diameter of the small wire with the help of the micrometer screw. With the help of the spherometer, we can measure the radius of curvature of the spherical surface, and the least count of the spherometer is also 0.001 centimeter. You can also find out the thickness of the slit using the spherometer. So this is the direct method. Now in the indirect method, indirect method is used only for measurement of very large distance, like distance between earth and planet. So with the use of the indirect method, we can find all this large distance. Now another method to find out the very small distance, like the size of the molecule, we have to use monomolecular layer method. So this method is used for very small size measurement, like the size of the molecule or the atom. The range is 10 raised to minus 8 meter to 10 raised to minus 10 meter. Now let us take what is the instrument used here. Now in this direct method, we are taking the first is the vernier calipers. You can see the picture of the vernier calipers, in which we can use the sphere or the wire to measure the diameter or the length of this object using the vernier calipers. Second is the meter scale, which we know very well. Another is the screw gauge or the micrometer screw, and third one is the spherometer. With the help of spherometer, we can also find out the measurement of the spherical surface radius of curvature. So this is the direct method. Now another second method is the indirect method. So to find out the large distance, we are using the parallax method. So what is meant by the parallax method? When you hold a pencil in front of you against some specific point, example a wall, and look at the pencil first through your left eye A, close the right eye at that time, and then look at the pencil through your right eye B, closing the left eye, you would notice that the position of the pencil seems to change with respect to the point on the wall. This is called the parallax. So in this parallax method, generally we are taking the one object and our eyes sees this object in two dimension. But if you close your one eye, then there is a one dimension, so you can see the pencil in one direction. And in the same way, if you close the second eye and open the first eye, then you can see the pencil in the other direction. So these two directions that make some angle at your eye point, so that angle is known as the parallax angle. And This method is known as the parallax method. Again, when you open both the eye at the same time, then you can see the object in 2 dimensions with the original depth. So this is known as the parallax method. Now we can use this parallax method to find out the large distance, like the distance between Earth and the Moon. So indirect method, to measure the distance D of a far away planet, we observe it from 2 different positions of the observations A and B on the Earth, and fix the directions of observations with respect to distant stars. For example, observing a planet P simultaneously from 2 points A and B situated diametrically opposite on Earth, we get 2 directions of observations AP and BP. Since the distance of the planet from the Earth is very large compared to the diameter of the Earth, angle theta will be very small. This angle theta is called parallax angle or parallatic angle. According to the definition of the radian, theta is equal to arc upon radius is equal to AB upon AP is equal to distance between 2 places of observations, that is the small b, upon distance of the planet from the Earth, that is capital D. So capital D is equal to B upon theta, and theta is given by small b upon capital D. So from this we can find out the capital D distance, that is the distance between Earth and the planet. Here AP and BP are same, as well as if you take the middle point of the AB, suppose the M, then MP is also equal to AP and BP. So in the same way we can also find out the size of the planet small d. The second figure is given, in which the parallax angle is the alpha. Alpha is small d upon capital D. So small d is equal to alpha into capital D. So now we can take how the indirect method is practically applicable. Actually, if we are taking this geometrical diagram, then we have so many question arises in our mind. But let us see the practical method. Now practically how scientists found large distance. Let us understand using pictures below. These pictures are given by the scientist. Now first picture, in this first picture the A position denote the Earth position at the current time, suppose, and the P position, that is the at the P position there is a one planet given, and around the planet there are so many stars which are very far away distance from the planet. Second figure indicate when 6 months completed of the Earth, then Earth is coming at the B position. So initially we are taking the observation of the planet P from the A position of the Earth, and we denote the knots in our notebook with the direction and the angle. Now when the Earth is coming at the B position, then again we denote the angle and the direction in our knot. So here we get the 2 direction AP and the BP, and by combining this we get the angle. So at the A position and the B position, actually we are taking the photographs using the telescope and the other high technological devices. So you can see the photograph of the planet when there is a position of the Earth. You can see the left figure in which the planet is there and the stars are around that. The star position is not changing because it is very far away from the planet, but planet is somewhat nearer to the Earth, so the position of the planet is changed after 6 months. Second figure. Now by combining these two figures, we get the some shift between two position of the planet. You can see in the fifth diagram, this is the shift. So by taking this measurement of the shift and other definition of the angle, we can measure the distance between Earth and the planet. So here Earth position first on capital A, and using telescope we note it and take photo of selected planet. After 6 months, Earth reach opposite side at the capital B, and at that time we again note down its position and we take photographs of the selected planet. Now as planet is near and other stars are far away, so stars position does not varies, but in planet's position we get variation. See the fourth and fifth photograph. Now that shifts are calculated, and from the radian definition we or the scientist can find the large distance. So in this way we can practically check what is the distance between the Earth and planet using this parallax method. Now let us understand how to solve example based on parallax method. So first we have to understand conversion of angle units. If we take a circle, it possesses 360 degree or 2 pi radian. So 2 pi radian equal to 6.28 radian. That means 2 pi radian is equal to 360 degree is equal to 6.28 radian. So pi radian is equal to 180 degree. That means 1 radian is equal to 180 upon pi degree. So this is the simple conversion between radian and the degree. See, we are taking the unit of the plane angle is radian. It is the SI unit. But there are other unit, that is the degree, minute and second. So we have to convert degree, minute or second into radian, and then we have to apply it in the example. So here 1 radian is equal to 180 upon pi degree, or 1 degree is equal to pi upon 180 radian. So you can see in the right side figure, in the circle there is 1 degree, and in the second circle there is a 1 radian angle. So 1 radian is how much degree? It is the 57.32 degree. So 1 radian is bigger unit of the angle. Very small unit of the angle is second or the millisecond we can take, but generally we are taking the second or the minute. So now unit of the plane angle is degree or radian, but small units are minute and the second. So 1 degree equal to 60 minute is equal to 3600 second, or 1 minute is equal to 60 second. 1 degree is 3600 second in this way. So 1 degree is equal to pi upon 180 radian. Same way 1 minute is equal to pi upon 60 into 180, that is pi upon 10800 radian. That means pi upon 10,800 radian. If we convert it in numerical value, then 1 minute is given by 2.91 into 10 raised to minus 4 radian. Same way 1 second is pi upon 3600 into 180 radian. That means 1 second is equal to 4.85 into 10 raised to minus 6 radian. Remember that SI unit of plane angle is radian. So must convert degree, minute or second unit of angle into radian unit to solve the physics problem. Now let us solve example 1, that is the illustration 1. The moon is observed from two diametrically opposite points capital A and capital B on Earth. The angle theta subtended at the moon by the two direction of observation is 1 degree 54 minute. Given the diameter of the earth to be about 1.276 into 10 raised to 7 meter. So compute the distance of the moon from the earth. So here the details are given. Theta angle is equal to 1 degree 54 minute is equal to 60 plus 54 minute means 114 minute. That means theta is equal to 114 into 2.91 into 10 raised to minus 4 radian. Here the b small b is equal to capital AB is equal to diameter of the earth is given 1.276 into 10 raised to 7 meter. You can see in the rough diagram, earth is given with the two diametrically opposite point A and B, and it subtends the angle theta at the moon, and the distance between earth and moon is capital D. The angle is theta. Now capital D is equal to small b upon theta equal to 1.276 into 10 raised to 7 upon 114 into 2.91 into 10 raised to minus 4 equal to 1.276 into 10 raised to 7 upon 3.32 into 10 raised to minus 2 equal to 3.84 into 10 raised to 8 meter. So distance D is equal to distance between earth and moon is 3.84 into 10 raised to 8 meter. This is the answer. Now let us take another example. When the planet Jupiter is at a distance of 824.7 million kilometers from the earth, its angular diameter is measured to be 35.72 second of arc. Calculate the diameter of the Jupiter. So in this example, capital D is given 824.7 into 10 raised to 6 kilometer. 1 million kilometer equal to 10 raised to 6 kilometer. Angular diameter is 35.72 second is equal to 35.72 into 4.874 into 10 raised to minus 6 radian. So here we are using the definition of the angle theta equal to D upon capital D. So small d is equal to theta into capital D is equal to 824.7 into 10 raised to 9 into 35.72 into 4.874 10 raised to minus 6 is equal to 1.435 into 10 raised to 5 kilometer. This is the answer. Please make a correction in second line of the answer. There is a 825.7 into 10 raised to 9 meter written. Instead of it, write down 824.7 into 10 raised to 9 meter. Thank you. Next time we will take the monomolecular layer method and other theory of the measurement. Okay, thank you.